Hi students, today we're going to be looking on resultant vector. The objective today is to determine by calculation or graphically the resultant of two vectors at right angle limited to forces or velocities, which means by the end of the lesson you're supposed to be able to determine the sum of vectors in different situations. But before we continue, let us start with a quick recall of the definition for vector. Vector is a quantity. Vector quantity is one with both magnitude and direction. Example: velocity, force, displacement, acceleration due to gravity. Vectors are usually represented using arrows. The length of the arrow determines the magnitude, and the arrowhead shows the direction of the vector. Now let's look at what resultant vector is. Resultant vector is a single vector representing the combined effect of two or more vectors. It's there to show the total magnitude and the direction of the combined vectors. In order for us to explore vectors, we're going to go to FetLab simulation to do so. In Google, you can type FetLab simulation, type vector addition, and you should be able to see the screen. From this screen, we're going to click Explore 1D. Pause the video while you search for the simulation. We're going to click and drag vector A to the grid. I can make vector A smaller or larger by clicking and dragging on the arrow. Vector A is 5 units long and it's pointing to the right. I'm going to add vector B and I'm going to make vector B 3 units long. If you notice at the top, the value is there. I'm then going to click on the word sum and values so you can see the values as well. And we get the resultant, which is denoted with the letter S and highlighted yellow, which gives us the resultant of the two vectors. What do you notice about the resultant of parallel vectors that are pointing in the same direction? Pause the video and create two examples of your own. Please ensure you make a note of what you noticed. I want you to also sketch both examples that you would have created in your notebook. There's another scenario that we can observe. What if the vectors were in opposite direction? So I'm going to clear the screen. Let us say I had vector A, 5 units long, pointing to the right. Then I have vector B. I'm going to make it 3 units long and I'm pointing it to the left. What do you think will happen when I click sum? Highlighted, the sum is smaller. What do you think happens when you have two vectors that are parallel and they're going in opposite directions? I'm going to ask you to do two other questions on your own. You're creating your own vectors. You're drawing a sketch of them as well. Please remember to number and label your activities appropriately. We can draw vectors to scale using a ruler and a pencil. For example, if you have two vectors, 5 newtons and 10 newtons, and they're going in the same direction, whether that's up, down, left, or right, then you can use a scale of 1 centimeter to represent 1 newton, or 1 centimeter to represent 5 newtons. Please note that correction. 1 centimeter to represent 5 newtons. I want you to write drawing vectors by scale, and underneath it, you're going to demonstrate how you would draw using a ruler two vectors, 5 newtons and 10 newtons, going in the same direction. And you're also going to draw the resultant of those two vectors. If you wish, you can create your own scale if you do not like the one I have given you. So it's 1 centimeter to 1 newton. We use scales in graphs, in geography, so it's the same concept that you're applying to solve this question. Let's pause and do on interactive, a quick activity looking at vectors in that are parallel going in the same direction or parallel going opposite direction. I want you to make an attempt to do this in your book first and observe your answers. For number one, if you have 4 units, meters per second, and 2 meters per second, and they're both going east, I expect your answer would be 6 meters per second, and it would be also going east. The length of the line that you have there must be equivalent to such a relationship. To the second question of 6 and 4, where we are going 6 north and 4 south, I'm going to change the orientation of the grid to be vertical. So I'm going to use D, going 6 north, and then I'm going to use E to go 4 south. And I'm clicking sum, and your answer for your sum, here it is, should also be 2 newtons, and it's going north because the vector with the larger magnitude is also going north. Great work so far. Now you're going to go to your textbook to page 52, and you will see more information on vectors going parallel and antiparallel. Additionally, our next lesson will be on vectors that are perpendicular. Have a look at what the concept would be like before you jump into the next video. Before we wrap up today, here are some key takeaways. Vectors have magnitude and direction. We denote it with an arrow, and the length of the arrow will tell us the magnitude of the vector. Parallel vectors can be added or subtracted depending on whether they point in the same direction or in opposite directions. And scale diagrams, vector scale diagrams, force scale diagrams, are used to help us visualize vector calculations and makes it easier for us to find the resultant. Hope you understood concepts from today. Rewatch the video if needs be, and write down your questions and take them to me next class. Bye.